Hey everyone, how are y'all doing? I'm Chris. We're going to let people filter in slowly, but welcome to our Blueprint Snap webinar. We're excited to talk to you about it today. Um, as people filter in, go ahead and join us in the chat. Make sure chat is set to everyone. Sometimes Zoom defaults to panelists only, and then only we can see it. But let us know where you're joining us from. And then what is your favorite thing about fall? Do you like the leaves, pumpkin spice lattes? I don't know, other fun stuff that might come with fall.
Maybe you're
Um,
like me and love the really dark, raining days, which is happening right here in Washington. Makes me so happy.
that is wonderful. I'm in Denver and like the sun is not as aggressive as it was, but it was like 81 on Sunday, so it's a little confused right now. All right, we'll let people sort of filter in, but we'll go ahead and get started so we stay on time here. Um, Please use the Q&A feature. There's a Q&A feature in Zoom that just helps us keep track of the questions. We have a great mod team sort of in the background that will be answering questions for us, but we just don't want anything to get lost. So use that Q&A feature if you have any questions. We will have a Q&A session at the end. If there are any lingering questions, we're happy to answer them at that point. This will take about 35 minutes or so. And it will be recorded and emailed to you afterwards along with your PD certificate. So don't worry about that. We'll be sending it out. We just ask, give us a little bit of time. It usually takes about 2 business days or so to get our ducks in a row. And I'm here with Anne. Anne, tell us about yourself.
Hello, everyone. I'm Ann Goodwin, and I'm a solution architect here at Sphero. If you joined us in our last webinar, yes, I have a different job title now. How exciting. I'm a former elementary teacher and instructional technology coach. And as mentioned, I'm here in Washington State. And yes, I will always want to see photos of your cat.
It doesn't even have to be their cat. It could just be a cat that you see.
Absolutely. Absolutely. Cat, I want to see it.
All right, I'm Chris. I'm on the education content team. So I used to be a teacher in Chicago. I've been in curriculum development for 10 or 11 years, making fun stuff for your students to learn on. I also enjoy making sourdough, and that might be my favorite thing about fall is I can finally make bread every week without turning my kitchen into a sauna. Um, all right, and what are we doing today?
We've got a full agenda for you. We're going to start with what SNAP is and who is it for. We'll cover the why and how and dig into the anatomy of a lesson. We'll cover this concept of I'm not an engineer. What am I going to do with engineering design process? And we'll end with a poll and some time for Q&A. So take it away, Chris.
Great. And hi, Diana from Northeast Tennessee. I love watching the colors change too. I'm originally from Wisconsin, and we get very colorful falls in Denver. It's a lot of yellow and browns. It's a little sad, but we have beautiful mountains to make up for it. And Nicole, pumpkin pie. That's always good. I'm not a big pie person, but like pumpkin pie in the fall just tastes good, and I don't know why. All right, let's get started. What is Snap and who is it for? If you've been to other webinars or maybe you've seen our products before, you might have seen this slide. It just has our entire portfolio of products. On that x-axis, you can see grade levels pre-K through 12. And then on the y-axis, you see sort of these skills that students will be working on regardless of product. So that's the collaboration, critical thinking, engagement, and stuff like that. On the top, you see two blue blobs, Blueprint Snap on the left. That's our elementary engineering solution for grades 3 through 5. We really focus on the engineering design process. I'll be saying that a lot today. But we also bring in a little bit of creativity, some cross-curricular stuff, and you don't need an app for it. And Blueprint Snap is sort of the precursor to Blueprint Engineering, which is our middle school, high school product. That's more ME, mechanical engineering and electrical engineering focused. We bring in CTE, we bring in math, we bring in science. You'll be calculating the ideal mechanical advantage and stuff like that. But we're talking about Snap today. And what will you be learning when you use Snap? I said I'm going to say engineering design process a lot. I will say that a lot today. It's kind of the root of all of our lessons that we're launching with Snap. And you'll see sort of I go through a walkthrough of what that looks like in our lessons in a little bit, and then also how we apply that in an industry. We align to NGSS standards and STEL standards if you're interested in those. There's like a million different places you can find standards alignment, and I'll show you what that looks like in a little bit. If you like standards as much as I do, get excited. And then all of these pieces. So a kit comes with a lot of stuff. If you're familiar with blueprint engineering, some of these might look familiar, but then you might be like, hey, there's something that's very different, and that is our color scheme. So this serves a few different purposes. One is it's fun. Like when you make a large build with all of these different colors, it's really exciting to see. It's fun to see. It looks really cool. But also, like if you've so these trusses are sort of the foundation of our entire build system. It's how you build big structures. There are long ones like this 10 by pitch truss, and very small ones like this 1 by pitch truss. And if you've got a tub full of trusses and you're looking for a 1 by truss, it can be hard to find, but no longer because the pink one is the one it's easy to see. You can find it at the bottom, so it helps in that sense. It also really helps students if they're looking at an image and they're trying to figure out how to build a prototype based on that image. They can identify these parts really easily. So they can say, oh, that's a 3 by pitch and a 2 by pitch that are connected together. Those trusses are connected together. It's not an orange 5 by pitch truss. Or maybe that's a lock plate. It's purple. It's not a yellow connector. So it also helps students sort of build prototypes faster and identify the pieces a little bit easier. There are also some new things. I've been waving around this ring tool. It's my favorite piece of the kit, and I'll go into depth of like how we created this and why it's so useful. Really good tool to sort of take things apart, put things together really quickly. Then we've got a spool, a rope anchor, new ropes with tethers on them that make connecting ropes to things much, much easier. We've got capped shafts, which is just a shaft with a little butt at the end. If you are using gears or pulleys, it makes using them a lot easier and they stay in there a lot better. And then we've got this little friend. It is the cardboard clamp, and you won't be able to see it all that well. It's a connector on one side, and then it's got a little clamp with teeth on it on this side. And like the name would suggest, we use it to connect cardboard to your builds. So maybe you're making an inclined plane and you're like, oh, I'm going to turn this into a slide. You can cut out some cardboard and affix it to your build. Maybe you want to add a little bit of creativity. You have a castle, you build a castle, you're like, oh, I want a castle wall. Maybe I'm going to paint that cardboard to make it look like old stones. You can use the cardboard clamps to connect the cardboard. And that's bringing in that creativity and that art a little bit more into Blueprint Snap, which is fun and exciting.
You said the removal tool was your favorite, Chris, but my favorite is the cardboard connector. I love that thing.
It is a lot of fun, and you can do, I mean, the tool, I play with it a lot, so that's probably why I like it. But like this, seeing what kids can build using like just cardboard and integrating that into their build systems, I think that's a good choice, Anne. It's a fun piece, and we'll see a lot of exciting stuff from teachers and students.
Agreed.
Okay, so what are we going to do with all these parts? So these are just two examples from two of our lessons. On the left, you have a drawbridge. On the right, this is from a castle defense lesson. That's a portcullis. You can lower it and raise it to keep people out or let people in. And so I mentioned engineering design process is sort of the foundation for all of our lessons. What we do is we don't have a prescribed build. Like we don't say, hey, build this drawbridge exactly like this. We give students a set of success criteria. As long as you meet those success criteria, you can build it however you want. So there's like a million different ways that you could build a drawbridge. This is just one of them. As long as you meet those success criteria, you're good. So this is where we're letting students just sort of play around and be creative with whatever their build is within those constraints of the success criteria. And we'll go a little bit in depth into what that looks like in a little bit. Okay, Anne, why Snap?
Why Snap? Well, Snap was made intentionally for the elementary space. And as I shared, I'm a former elementary teacher, so I absolutely love that. And in any classroom, we know how valuable time is. And one thing that's really cool about Snap is that there's no screens needed. It's all hands-on building components. And because there's no screens, right, that means it's that much faster to get to the learning from the time the bins come out to the time you start building a lesson. Also, internet down, because that never happens. No problem. You don't need any device. You don't need power for anything. You can just build, build, build. Snap is super hands-on, and we know that concepts are a lot stickier for kids the more time they get to be hands-on with the learning. And that's what Snap's all about. What better way to learn all about motion than building motion into a structure like some of those that Chris was just showing? We've got this concept of reusable consumable I like to think about. As a former elementary teacher, I did a lot of hands-on learning in the classroom, but I was using a lot of things like paper, craft sticks, pipe cleaners. And inevitably, there was always so much tape everywhere. And don't even get me started on glue. It truly is amazing how much glue gets everywhere, even when you're working with fifth graders. With Snap, students can just build again and again and again and take it apart, and there's no need to clean up a bunch of glue and tape. And of course, you can do the craft experience alongside of that with those cardboard connectors like we were talking about. And last but not least, student creativity. That's what we are so excited about with Snap. They get to be incredibly creative. The lessons that we have out now really build in those experiences for students. Like Chris was saying, there's no right answer with the builds. We know that students are really needing that time to be creative and imaginative. And it's really valuable for them to get that experience having a list of constraints and then building to satisfy that list rather than always working towards everybody doing the same thing. I know I would get asked, is this right? This is a great opportunity to get students self-evaluating. In the school day, there's a lot of things happening in the school day, and there's never enough time. But with here at Sphero, we've got tons of former educators on staff, so we are always thinking about how experiences fit into the school day, and we think Snap makes a great fit no matter what your day looks like. If you are teaching in the general education classroom, there are tons of ways you might use Snap to get kids engaged further in the concepts that you're already teaching. In writing, it can be really hard to get students started. I know I really struggled with that. Using Snap, students could build an invention and then write all about it, either technically, as in steps to build, or really imaginatively, like how the magical creatures are going to use this invention to save their world. If you're thinking about math, measurement can come in really quickly. Like Chris was holding up earlier, each pitch or unit on a truss is 25 millimeters long. So you could build and measure in millimeters and work on conversions, or start with a calculated area and then have them build something to match those or equal that total area. And each weighted pitch, we have some of those as well. They are equal to 25 grams each. So it's really easy to bring mass into the equation. Ha ha ha. And STEM and makerspace teachers, I hope some of you have joined us today. We know you are all about that hands-on learning. You could do free builds, bring in with creativity. You could build something that follows a set of constraints like we were talking about, or maybe you're going to bring in robotics, like building ramps or bridges with cardboard and those cardboard connectors, and then get Indie or Bolt Plus to navigate on them. And then with extended day and enrichment programs, you can use any of these ideas to bring learning to your spaces. We've got some examples here to help you imagine that some more. First up is a temple modeled after the Mayan civilization, and that comes to us from our ancient engineering lesson. And next is a big toy. I was so glad to see big toy. That's what I called it when I was a kid. You can see there's a slide and a zip line and a swing, and this comes to you from our Snap Playground lesson. And last but not least, a trusty car from our Design and Drive lesson. And I know when I was looking at these, right, the creative wheels were turning for how I could bring some of those core content connections in that we were just mentioning, like writing and math. Now you might be wondering, how? How do I see all this amazing content? Well, we've got Sphero Central for you. We are always talking about Sphero Central. As I mentioned, oops, I'm on my wrong thing here. This is the place to be. This is our teacher hub for all of our collections. We've got lessons, resources, videos, more than you could imagine. When you first go to Sphero Central, you'll be able to navigate to the Snap section right on the homepage by clicking on the picture, or there's a little drop down at the top and you can click Snap from there. Once you get on the Lessons tab, you'll find that we have those 3 collections ready to go for you. And Chris is going to walk through a lesson in a little bit so you get to know all the components and see how a lesson is aligned to all the standards. And one of the really fun resources to check out on Sphero Central is the Snapopedia, which is just super fun to say in general, Snapopedia. You'll find pictures of all of our parts in there, including that are included in the Snap kit. And when you click on one, you can find out more information all about it. And then in your kit, any print copies of things you receive, like an educator guide or challenge cards, there'll be digital versions of those on Sphero Central as well. And all of these resources are totally free, and you can explore them at any time. And our amazing content team, including Chris, they're always working to add more. We've got 3 collections ready to go already. We've got Strong Structures, Made to Move, Dream It, and Build It. And each of these collections features 5 lessons. In Strong Structures, students will use the engineering design process to develop, test, and iterate on prototypes of real-world structures. The collection kicks off with a lesson called A Bad Bridge, which is really fun. You do just that, you build a bad bridge, and you have to figure out how to make it better. And we've got a really great video that has that lesson overview that we can drop in the chat for you. In Made to Move, students will explore motion with real world prototypes and the engineering design process, building things like cars, swings, and even a drawbridge, which is so fun. Anything to do with castles, I'm in. Dream It, Build It is a collection that features more open-ended builds and has opportunities for deeper research and cross-curricular activities. And then, as always, you'll find an educator guide and challenge cards to get you started because we want to make sure you're set up for success. And these are on Sphero Central right now, so feel free to explore these and see what you can find. There are 15 challenge cards, excuse me. And working through these challenge cards will help kids get really familiar with building with Snap, the different parts that are included, and those best build practices, like using that removal tool that Chris was showing. And the last 4 of the challenge cards are really fun. They're very open-ended and creative, where students can use all the skills they gained through the other challenge cards. And Chris is actually going to give us a little tour right now of Sphero Central.
Oh. So Cassie's put a bunch of links in the chat, so click those if you want. And when you go to Sphero Central, this is what you're going to see. You're going to see our product lineup. We're going to scroll down here and look at Snap. If you're getting started, you're not sure what to do, this is a great place to start. We've got some ideas of what you should look at. There's the challenge cards and the lessons and resources. Down here, we also have FAQ, and then if you need to contact our support team as well, you can do it right there. Switching to the lessons tab, we have 2 different sections here. One is the collections Anne is talking about. Those are organized by theme, and then you can click lessons, and these are each of the individual lessons themselves. In resources, we've got 2 tabs. Here's the link to that educator guide, challenge cards, the poster that comes with the educator guide of that engineering design process, links to those videos here. And then in the more resources section, we're building this out as we hear, what teachers want from us. But maybe you're into CAD and 3D printing, and here you can download the step files. We also have a kit part list to see all those pieces. And then the fun to say Snapopedia with each of these pieces. And if you ever get stuck and you're like, hey, I don't know what this thing is, it's like a connector with a thing pointing out of it. You can come here, learn a little bit more, see how to use it. Sometimes we have hints on like, maybe this isn't how you should use it, so don't use it that way. So the Snapopedia, if you want to learn a little bit more, it's a fun place to hang out. I will come back to that in a second, but I am going to take a look at our lessons. So I'm going to use one example here. So this is the drawbridge one. It's a reoccurring theme. We like bridges. But so the first page in a lesson guide, and I will open it up in a second, has all of the information for you as the teacher. So this is in a Google Doc, but you can download a copy. You can download it as a PDF or a Word doc if that's your thing. We've got an overview, the objectives, the standards, links out to a student handout and to lesson slides that you can use. And then these last 3 sections, key vocabulary. So if there are any terms or phrases that we use in this, we'll give them to you there. So you can sort of front load that along with their own definitions. In preparation, we're like, if there's anything you need to know or your students need to know before this lesson, we give you some hints here. So there are some other bridge related activities. So we suggest, hey, maybe check out those before you do this one so that your students can sort of build on that background knowledge and make sort of more elaborate drawbridges. And then possible extensions is the last section. This one, one thing we really like about our content is that we give it to teachers and they're like, oh, here's 6 more ideas that I have based on this. Anne has brought this up like every time she meets a teacher, she's like, they've got 30 more ideas just based on this one
Yes,
lesson.
teachers are amazing. They are full of ideas.
They are. So what we're doing is we're just kind of trying to set that seed there for like, here's some more potential ideas. This is like a 45-minute lesson, but if you want to expand on it. So we're looking at drawbridges, we're talking about castles, but movable bridges are still popular today. Like I used to live in Chicago, they have more movable bridges than I think any city in the world. So maybe you turn this into a research project where they look at different movable bridges, maybe where they live, maybe somewhere else. They make prototypes with Snap and then present it to their class. So we try to give you some ideas of like, hey, this is how you can take this lesson, spin it, make it your own, and have a little bit of fun with it. So after this first page, we have the lesson itself, and this is broken into 4 different parts. And I mentioned all of our lessons that we're releasing here are based on this engineering design process, and that's what is happening here. So we've got brainstorm and plan, design and build, test and improve, reflect and share. And I'm going to go back to Sphero Central just to kind of give you an idea of what that looks like. So I'm going to go into the Made to Move collection. Here we also have those standards. I said you can find them in a bunch of different places. If you want to see the alignments for this collection, you can click on that. But I'm going to go into drawing a bridge. We have our overview, we have our objectives. Under See More, you can see those standards again. I told you we got them everywhere. And then some tags for searching that for subject area. Here we can click on our lesson guide. And this is sort of your hub for everything you need. Okay, so we have links to the student handout in here. You can make a copy of your own. We have links to lesson slides that you can use to present while you are teaching. Here's that sort of preparation page to get you ready for the lesson, and then we get right into it. So step 1, anytime you see these little conversation bubbles, you're going to have a discussion with your class. In italics, we have suggested language. You don't have to use it. A lot of teachers will just look at it and kind of be like, oh no, I got this. And then other times, this is a really good starting point to start a discussion with your students, just kind of activating prior knowledge, kind of hooking them into this. And then you go into introducing the challenge. So we mentioned before a couple times, we have success criteria for all of these lessons. So for this lesson, your drawbridge needs to be stable and securely attached to a base. It has to be at least 4 pitches and wide and 5 pitches long. Again, we have the millimeters in there. So 4 pitches times 25 equals 100. If you want to do that with your students, that's fun. And then it has to be able to move freely from a lowered to a raised position. So it's got to go up and down. So from there, like whatever your drawbridge looks like, it's cool. Like there's a lot of different ways you can do it. There are a lot of different parts and pieces in this kit that can help you do it. As long as it meets the success criteria, it's cool. So we give students a little bit of time to sketch out their ideas. If we go up to the handout follows the same framework. So here we have brainstorm and plan. They've got some ideas here. If you want to print this out, they can sketch their ideas. If you want them to do it digitally, they can write about them or maybe draw in the Google Doc, whatever works. And then from there, they move into the design and build period. So this is where students are getting their hands dirty. They're building their prototype based on those success criteria. Maybe you're circulating during this time. We have some suggested questions if you're like, hey, I want to encourage some deeper thinking, or maybe you want to do some observational notes on like, what are they getting? What are they not? And then we've got this little guy who's like a engineering tip. He helps you out. Gives you some background knowledge in different places. We also have some potential designs in here. And now you as the teacher can kind of decide whether or not you want to show these to your students. So maybe you show it at the beginning to kind of get those creative juices flowing and like, okay, here are 2 potential designs. What are you going to create? Maybe you don't want to show them at all. And you're like, just kind of go wild and see what your students come up with. But we do provide those here just in case you want to get some ideas of what they might look like.
You could even build one ahead of time to have to show kids in real life and be like, look at this.
Yeah, teachers got to have fun too. I like one of the ways to prepare for these lessons, a fun way would be to, build your own design and then share that with your students.
Absolutely.
Yeah. All right, then we go into test and improve. In the student handout, they'll be identifying a strength and weakness, and then we move into reflect and share. So students will have time to reflect on their builds, on their prototypes, what worked, what didn't. There are suggested discussion questions that are also in that handout. During this time, you can sort of circulate and check in with a few groups and say, hey, would you be willing to share your prototype and your responses to these questions? And then you facilitate a group discussion around like, hey, this is what worked, this is what didn't. Focusing on that failure is really good, especially if you can sort of share it collectively of like, oh, this was my bridge fell apart because of X, Y, and Z, but then we did this. Celebrating that failure is always really good for students to see, and adults too. Failure is good as long as we learn from it.
And
So
Chris
that's the
mentioned there's the cool poster that comes, so you can have that up on your wall so students could really easily talk about the poster and say, well, I used this part of the engineering design process.
There you go. Okay, let's see here. So that's sort of an anatomy of a lesson. Feel free to, go through Sphero Central. As Anne said, they're all there, available and free. And you can kind of see all of the different parts and pieces and lessons that we have so far. We've already got another collection in the pipeline that we're working on right now that we're excited to share with you in a little bit, and then also maybe get some ideas from you at the end of this.
Now, Chris, this is an important question
Mhm.
because I'm not an engineer, and
Mhm.
I'm sure some teachers are listening and they're like, I'm not engineers either. So what am I going to do with engineering design process? Tell me.
Yes. So if you're a teacher, I want you to imagine a time where maybe you planned a lesson and you're like, okay, these are my objectives. I'm going to introduce the topic in this way. I'm going to assess my students in this way. And then you started your lesson and it didn't go as planned. Sometimes you can sort of react in real time and adjust and course correct. Sometimes later that day, you're like, oh man, what did I miss? There's this background knowledge that the students didn't have that I need to introduce, or maybe my assessment was a little bit off from my instruction. So you make some changes and you do it again, and it turns out better. So I think what I really want us to take away from this is the engineering design process is really just this iterative cycle of making things better. And that's true, like whether you're an engineer or whether you're not. And you might get this question from your students too, of like, I'm not going to be an engineer. Like, why do I need to learn this thing? But like, if you're a musical artist, like the lyrics that you write first are not going to be the ones that make it on the radio. If you are writing a book, your first draft is not the book that's going to get published. Really focusing on this concept of creating a prototype, thinking about the problem, making things that work and don't work, learning from them, and improving is really important. I have an example. So I said ring tool is my favorite. So I kind of want to go through this. Like Anne, I'm also not an engineer at all. But in producing this ring tool, I went through the engineering design process many, many times over the course of several months to figure out like how did we land on this design. So if you look at that top row, there are some sketches. We kind of gave our creative team some ideas of like, hey, we need something so that kids can, take apart blueprint pieces, remove the trusses, remove the connectors, but they're not going to have as much strength or dexterity as our middle school and high school students. So what can we do? They produced like 30 of these sketches. Some of them were good, some of them were terrible, some of them were really great, and we wanted to do that, but we just couldn't. But we sort of winnowed and sifted through these designs. In that bottom left-hand corner, you see our mechanical engineers then took over and CAD'd these out and created 3D printing files where they would send me the file, I would print them on my 3D printer and start testing them. So in this middle picture in the bottom, I've got a bunch of different 3D printed variants of this. We had a loop tool, we had a ring tool. They were kind of battling against each other for which one we liked best. We sort of like originally started with this tail here, and we were like, oh, that's really cute. It's like the Sphero tail. But then as soon as we got it, we were like, wait, could we use this to separate trusses? And we ended up mangling the original tails because it was skinny and small and thin. And we're like, okay, we need to iterate on that. So we went through a bunch of iterations to make sure that this tail could be used to separate trusses just by twisting. And then we also went through a bunch of iterations just on the placement of the shaft that was coming out. And we landed on this orientation because you can kind of put your finger in and use it as a handle like this, and you can twist if you're separating, say, a plate from a truss or maybe two trusses from each other. Or if you are like removing a connector, you can turn it around, go like this and stab those connectors and pop them out real easily. There's a GIF here. This is my daughter. She's 5, so she's not our demographic, but she's been using Blueprint since she was 2, so she's pretty adept. And she just holds on to it like this and just pops those connectors out real easily. And this wasn't just me sort of in my room kind of playing around with this. We put this in the hands of students and saw what worked, what didn't. I would 3D print some new designs, go back to our engineers, say like, hey, this needs to be fixed or this doesn't work. So this was a whole cycle over the course of several months. And like this went through, I don't know how many different designs. So I think that's just an example of one non-engineer, me, going through this engineering design process. But there's also an example of like, how is this actually used in industry? How is this practical if you actually want to use it in the real world? So fun tool. I am biased though because I spent a lot of time with it over a long period of time.
It's just the coolest to see the behind the scenes of that whole process. When I first saw that slide you put together, Chris, I was very wowed. I did not know there were all these drawings. That was the first time I had seen all that.
Yeah, it's really cool. And I think the creative team probably has the hardest job because they create all of these really great ideas. And then we're like, no, 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 no. So I think, it was a fun process. It's sometimes frustrating, but, we came out with a really cool tool. And I think your kids are going to love it. Okay, Cassie, I'm going to ask you to help me with this poll. We're going to put this out here. So Ann and I have talked about like teachers have really, really great ideas, and we like to hear from teachers and figure out like, okay, what lessons should we create? What resources do we need? Where are people getting stuck, and we can support them. So this is a poll right now. Go ahead and put in your responses, and we just want to learn a little bit more. Like, what would you like to teach with Snap? How interested are you in like maybe if there was an electronics component? Give us your thoughts, and we'll let this poll run for a little bit. And we always appreciate your feedback.
Feedback is so important, and we take it to heart and we make sure to read everything that you tell us. So now's your opportunity. Lay it on.
And Danielle, I see a very helpful tool for the little ones still building those fine motor skills. Yeah, that was one of the biggest sort of considerations we had in doing this is if you're familiar with the Blueprint tool, it's kind of just like a long lever with a shaft out of it. And it works really well. It's very effective, but it's, if you put it in the hands of the small hands of people, it's not that effective. So this one not only looks fun, but it's a lot more practical, and hopefully they can use it a lot easier too.
When I first started using this, I thought, okay, I'm going to put my fingers in the hole. That's how it's designed. But when I started building with it, I noticed I was holding it just all in my hand, like a little kid would. That was most comfortable for me. Maybe I have small kid hands, I don't know. But
Yeah.
it's really neat that you can just use it in a variety of different ways.
Yeah, and we definitely saw variants too, like where, like I can only fit one finger in here, but there are kids that can fit several, so they like have a big old grip on it. There you go.
Yeah, I can put two fingers in
There you
it.
go. All right, we'll give you a few more seconds on this poll. Thank you again for responding to it. Like I said, we've got a lot of ideas. We have this long backlog of lessons that we're excited to create, but we also want to hear from you and what would work in your classroom. So thanks again for that.
It's going to be really exciting when kits are in the hands of kids and we get to start hearing from teachers who are using this in their classrooms and seeing all the really neat things that kids are going to build. I just know they're going to create the coolest castles.
I am excited for the castles, yeah. And I think just on like getting this in the hands of students, if you are looking to order this, we sold out of our first shipment already. But we will, if you place an order, we are, I believe, shipping about mid-December or so we should have our next shipment ready to go out. So keep that in mind. We already sold out of our first batch, but we'll be getting more as soon as we possibly can. All right. Cassie, I think you can end that poll. Is there any further questions that we missed? Do you have any suggestions for how you would start with Snap in the classroom? What would you do first? So I think that's a really good question. I think sometimes it's like, oh, I got, especially if you get a bunch of class kits and there's all these bins everywhere, what do I do first? Really starting, Anne mentioned those challenge cards. So there's 15 of them. We design those in a way so that it sort of slowly introduces students to the different parts and pieces, so that you can learn, okay, this is how I make a structure strong. Okay, this is how I add movement to a structure. Okay, here's how I add gears to a structure. So like it's progressively built out so that you can kind of start, and you're not only learning the different design principles, but you're also learning how these tools work. So we really recommend starting with the challenge cards. In that educator guide, you've got sort of step-by-step walkthroughs and more background information and stuff like that, for the teacher to see like, how would I implement this? Do I want to do it as centers? Do I want to do it as small groups? So those challenge cards, number one place to start. And also that educator guide links to those standards, so to the challenge cards and gives you ideas. And again, you can see those all for free right now, even if you don't have a kit and you're like, I don't know what that looks like. What does that mean? Go ahead to Sphero Central. You can click on the educator guide and get an idea of what that looks like.
And there's a lot of ways you could do the challenge cards, right? You could do one a day until you're done with all the challenge cards. You
Mhm.
could have them do three at a time, depending on how much time you have in your block with students. They will be physical cards in the kits, but there's also
Mhm.
digital versions, so you could project it up
Mhm.
on the screen so everybody can see at the same time as well. So lots of ways to use those challenge cards, but I'm with you, Chris. That is where I would start for sure.
Yeah. And then, so plans for next collections. Well, I don't want to give too much away, but we're working on, so these are a little bit more creative, and we're not so into like mechanical engineering, simple machine stuff. So we're creating a mechanical engineering sort of rooted in simple machines collection right now. I won't give away like how that's themed or how we're doing it, but it will be introducing students to what are the different simple machines, how can they be used, maybe you can have a little bit of fun with them. So that's what we have sort of, we're working on right now and we're excited to release. Um,
I know somebody
so
asked a question about if the pieces are the same as Blueprint. So if you're familiar with Blueprint engineering, you've seen some of these similarly shaped pieces. And spoiler alert, there's a lot of the pieces that are the same. They're just these really fun colors, but there are some really cool new pieces.
Yeah, Kelly, that's a good question. So this slide here kind of shows us all of the pieces here, and if you're familiar with Blueprint, you're like, oh, a lot of these look familiar. We've got a new ring tool. There's a spool there, along with rope
Cool.
anchor, spool, along with a rope anchor, and new ropes that have tethers on them. This just makes using the rope a lot easier. It makes the connection stronger. And that spool is, if you've used the pulleys before, pulleys are good, but it's hard to get a lot of rope around them. So our spool is sort of our solve for that. We also have these capped shafts at the bottom. So there are, our shorter shafts are all plastic capped shafts, which make holding those gears and pulleys together a little bit easier. And then Anne's favorite part is the new cardboard connector, that is a cardboard clamp, sorry, that looks like a connector on this side and then is a clamp with teeth on this side. And you can affix cardboard to your builds if you want to make a slide or a wall or something like that. So some familiar stuff, some new stuff, and all in bright new colors.
I'm very into color coding lots of things. So Snap really is satisfying to me in that way. I love it so much.
Yeah. How many students are recommended per kit? We usually recommend like 2 to 3 students, just in terms like there are a lot of pieces, but just in terms of like working together, I think 2 to 3 is a good number. Also keep in mind if you're using that student handout, maybe you want each individual using the student handout, maybe they're collaborating as a group. Think about that. But 2 to 3 students per kit is usually what we recommend.
And you could give them jobs. Maybe one's the engineer for a turn and one's the project manager, and they're taking notes with the handout on a clipboard, and they take turns. So there's
Mhm.
some fun ways to bring some careers into that as well.
Yeah. Let's see here. Could the new cardboard piece for the be for the blueprint kits also? So I think that's like, what could we add it to the blueprint engineering kits? We can't right now, but maybe in the future we'll have accessory kits where you can buy cardboard clamps individually and then maybe add them to your blueprint engineering kits. That's a good question. I think when we were, especially our engineers, because they have like we have a backlog of a bunch of really good lesson ideas. They have a backlog of like 1,000 different parts and pieces that they really want. So they get super jazzed about this. So like there's always a million different ideas of how we would do that. I'd say not right now. I don't think we'll add it to the engineering kit, but maybe in the future we have accessory kits to sort of maybe you can buy these parts and pieces and then add them to your engineering kit down the road.
But if you had blueprint engineering with you already, and then you had some snap kits also in your space, and that would be the coolest, yes, they would click together.
Let's see. Am I missing anything, Anne?
I am trying to keep an eye. I'm not seeing.
Oh, what is your favorite lesson?
Oh,
Sorry. I think my favorite lesson, Anne talked about this. We have a video walkthrough of a bad bridge. And I really like a bad bridge because I think it starts off with a prototype that is really just not good at all. The bridge falls over, it is not strong, is not a good bridge. And I think one of the things that I've seen with students is that like fear of not doing something that if it's not perfect, I'm not sure I want to do it, or maybe I don't know what to do, so I'm not sure where to start even. A bad bridge kind of gives you something really bad to begin with, and you're like, oh, I can just poke it and it falls over. Like I can solve that. Like that's a problem I can solve. And then from there, it's like, oh, I need to put some weight on it. Oh, I can solve that by adding plates or by adding more trusses. So I think starting from a place of like, this is a really bad prototype, but you can improve on it, can sort of highlight the sort of importance of prototyping not being perfect. Like no prototype is perfect, and getting kids comfortable with the idea of like creating something bad first and then learning and iterating on it.
I love it. Bad Bridge is great. I was
Yeah.
gonna say I did some training with our sales team internally, and we did one of the challenge cards where you make a winch, and I was teaching them all about parts, and I made them hold up all their parts and say the name of the parts because I'm a former elementary teacher, and it was just very adorable as they were holding up and saying spool.
Spool. All right. Okay, I think I got to all of the questions, hopefully. If I didn't, I apologize. So we're going to wrap it up here. Again, we're going to send this out, your PD certificate. The recording, Kelly, you said you joined a little bit late, so you can go back and rewatch if you want. I'm sure all of you will rewatch us a million times. But thanks for coming. We're excited to get Snap out into the market and seeing what teachers and students can do with it. Here's, if you have questions, training at Sphero for implementation or professional development, support at sphero.com for any sort of support, and then sales questions with that website, sphero.com/pages, meet the team. And then all of our socials if you're into that sort of stuff. But thank you very much. It was good seeing y'all, and I hope you have a great fall and a good rest of your Wednesday. Thanks,
Thanks,
everyone.
everyone.
Bye.